then so tonight we're gonna look at chi-square test, or the other word that we used is goodness of fit. So we will look at that tonight, and then also for some of the students that only joined in the last week or two, we're also nearly gonna start with a recap of study unit 1 as well, and build up that we get towards the exam preps and all those kind of things for you already, even though it's only end August, but just want to make sure that you get as much as possible of all the content in and those kind of things. Okay, so tonight going to look at the chi-square test, and basically what we're going to do in the chi-square test, and I think I'll show you later on as well, one of the summary slides that you nearly can just look at that summary slide, and whenever you get a problem on the study unit, you basically need to be able to answer 5 or 6 things. Okay, so we will get to that. What happens with a chi-square test is normally we're looking at they say contingency tables, but also nearly, if you call it, a crosstab. So test of independence normally look at 2 variables. Then within that, we nearly will set up a null hypothesis and an alternative hypothesis. The null hypothesis is always looking at your independence. So your null hypothesis will always look at if something is independent. Your alternative will be the dependent. So your null hypothesis will always be looking at the independence, where your alternative, H1 or HA, will always look at not independence, or sometimes I call it dependent. So again, we'll just, when we get to some of those questions, we will just see how they phrase it, but they can call it not independent or they can call it dependent. So that will always be your first starting point, will be that we need to classify it as the H0 and H alternative. Then the second component will be that we will get a table, and that table is then what will be your observed numbers. So when we get a table, they will need to at least fill some of those information in for you. So let's say we had variable 1 that was, say, eye color of brown and gray, and you lived in the Western Cape or in KZN or Gauteng. So, and let's add another, let's say blue, brown, and gray. Then they need to give you these numbers of how many people were observed in each group. So that is the observed frequency. Then they say that sometimes we will need to work out what is the supposed expected value of each of those cells. And there's a formula to work that out. So the formula to get this number is basically you take the sum of the blue, you take the sum of the white, you multiply it by one another. You multiply it by one another. So row total, column total, multiply it, and you divide it by whatever the total sample was. So, but you need to do that for all of them. So if you had a 3 by 3, there's 9 calculations that you need to make. So again, I'll show you in Excel a quicker way of doing that. So that's the first 3 steps. Then the fourth step is to say that one needs to compute the t-stat. Again, if you look at this calculation, it is a lot of work. So once again, we'll show you in Excel, because if you now need to work that out, you needed to say this number minus that number to the power of 2 divided again by this number for all 9 of them. So it becomes a real long way to work it out. So again, I'll show you in the Excel how to do it. The chances of you getting that you need to compute the t-stat in the exam is very slim. They will normally give it to you. It might be that in your assignment you might need to calculate it. But again, in the exam, very slim possibility because of the time that you need to use to calculate it. Then what you're going to do is, or you're going to look at the significance level that they give you. And like we used to do with the Z tables in the previous work, we also have a chi-square table that we're going to look at, and then we're going to compare that critical value to the test statistic, and we're going to decide if I accept the null hypothesis or if I reject the null hypothesis. The other thing that is important is that when we looked at the, what was it, the t-stat with a z distribution, there was a degrees of freedom in there, which was always just n minus 1. But when we work with the chi-square, it's a bit different. So we will look at how many rows there are. So rows minus 1, columns minus 1. So if we were looking at this one, we would have said, okay, there is 3 columns, 3 rows. So I would have calculated it as 3 minus 1 times 3 minus 1, because there was 3 rows and there was 3 columns. Okay, so the degrees of freedom is different when we're looking at the chi-square test, where we definitely, it is degrees of freedom row minus 1 times your columns minus 1. And you will see again in nearly all of the questions that this comes into play. It might be sometimes an easy one to work out, and it might be the quick one that might be wrong as well. So we will look at examples where we need to calculate the degrees of freedom every time. Okay, and then I think what is important, and I just wanted to show you, so this is a typical hypothesis, how it would look like. So your null hypothesis is for one that says it is independent, and your alternative hypothesis is for ones that says it is not independent. So another name for not independent can be that they say it is dependent. Okay, so again, when we get to some of the examples, I will just also make sure that we at least have one that use some other wording, just so that if you get something like that in the exam or in your assignments, that you are prepared for that and know then what to do. Okay, so the next piece of, so this is in your study guide, and I added it in here because what is nice about this, it gives you a very good summary of this chapter. So if you look at what we need to know about this study unit, we need to know the null hypothesis, the alternative. So that is normally your first thing. The second thing is that we will look at the degrees of freedom. The third component is how to work out the expected frequency if needed. We would get the observed frequency. Then we will need to check the test statistic. We will compare that to the critical value, so that we can then make a decision if we accept or reject the null hypothesis. Okay, let me I just want to open quickly the stats book to show you in the study guide. So if we go to the last two chapters, so at the back of, and you can see previous work. So at the back of study unit 10, here is the chi-square that we will look at the critical values, and I will show you how to look at it and how to use it in instances in the examples. And let me just clear that so that we can get to that. Okay, so again, this is, I'll share later on just with the formulas. You will also, I'll share with you some of the tables that you will use in the exam. But again, also the tables are in your study guides as well. So whichever one is the best for you. If you have one of the textbooks, it will be in the textbooks as well. So I like to have this on a piece of paper because then it's easier for you to reference it. But if you can't have it on a piece of paper, at least hopefully be able to open it up somewhere on your PC while you're doing the assignments, as well as by the end of the year when you need to write the exam. Okay, so let's get into what we need to do. So I basically, you will see there's a few different questions here. But let's just take that out. That we will go through. So the first one is you're looking at the contingency table. It has 4 rows. So it has 4 rows. It has 5 columns. So I just want to give you a visual of that so that you can just nearly see that. And then it asks you how many degrees of freedom. So this is just the chances that you will get something like this in the exam is probably very slim. You will more likely get one that is a full set of other things that you need to look at as well. But just for the principle that you need to know, so you basically, the formula for degrees of freedom for chi-square is rows minus 1, columns minus 1, and multiply the two together. So we know it's 4 rows. We know there is 5 columns. So it will be 4 minus 1 is 3 times 5 minus 1, which is 4. And you will get 12 as your answer. You will see that there will always be the number where you multiply the two together. That will always be one of the, if I look at degrees of freedom, where you would have just said 4 times 5. Okay, so that obviously is a mistake, but that will always be one of the options nearly when you're only looking at the degrees of freedom question. They will always have that in that part of the answer set. Okay, degrees of freedom, straightforward. Formula is the number of rows minus 1 multiply with the number of columns minus 1 to get the final answer. Okay, so then let's go to one where where is the rest of this? Okay, this is interesting. I have taken away the rest of this, so I will probably need to look where this is. Okay, we've gotten the 5%. Okay, so let's work this out. So the professor wants to test the independence of the two variables, and they give us a 5% level of significance. Okay, so what I would say, let's work out. I'm going to show you how we're going to work out the test statistic with that formula. Then I'm going to show you how we look for the critical value with a 5%, and then we will make a decision again, like in your hypothesis testing that we did in study unit 9. If a critical test is bigger than something, we'll accept or reject. So let's do that. But definitely this we do in Excel. So let's get a blank page. Let's make it a bit bigger. First, just want to put in the numbers, then I'll show you what we will do. There's also in Excel some formulas that one can use. So that's why I will tonight send to you, because we're nearly done in any case with this. Tonight I will send to you a file with all the sheets that you will need basically for the subject. I will send that tonight to you guys on our WhatsApp group. I'll also load the file into the My UNISA areas. Okay, so this was the data that they've given us. We can add total just so that it is there. They don't need to give you the total in the question. So let's just make sure that is everywhere. And then what we also can do is say, okay, but this was observed. So what we want to do is to work out what the expected values are. So the expected value basically is the sum of the one times the sum of the other, and then we must divide by the total sum. So we divide by the total sample. Okay. So then we need to do that for all of them. So I'm just quickly changing the formulas that we will be able to do that. Okay, so this was your observed numbers. We used the formula that they gave us, the formula of row total times column total divided by n. So that gives us those numbers. And you will see that those totals must always be exactly the same. So then you know you have done it correctly. So what we can now do is we can use again, that formula to work it out. So that formula, let's quickly see, it's observed minus expected. So it's observed minus expected. Looks like to the power of 2, and then divided by observed. I think what was it for observed? So let's just quickly see the expected. Sorry. And again, please don't remember this, and let's just right. Okay, so we will then need to do it for all 4 of us. So let's just quickly check that is correct. That looks correct. That looks like the right ones. And then that we then need to add all together. So it seems simple in Excel, but if you now needed to do this by hand, you needed to work out that 4 times then hoping that your calculations was correct there, then you needed to work it out again 4 times, and then add all of the numbers together. So what function there is also in Excel? Let's just say undo. Okay, so that was your final answer. Let's just make it another color. What you can also do is the chi-square function in Excel, you can use that. So your chi-square, let's quickly see. Let's see if it is that one. There's a few of them, so I just want to get the exact numbers. So the actual range is your observed numbers. The expected range is those expected numbers. And then hopefully, okay, so that's a bit different. So what did we work out here? We worked out actually the p-value and not. Okay, so let's quickly see if there's another chi-square test. You can see I don't use this a lot, so just want to make 100% sure which one we need to use. Okay, it's not that one. Okay, that was the one that we had. Just want to make 100% sure. Okay, so this one is not right because that takes you to a probability. Okay, so let me just see why this is different. And let's just see if the formula was right. So it is definitely observed minus expected square root. Okay, so observed minus expected square root, that answer divided by expected. So that is right. So let's just check then what else. Okay, so it every time gives you that. That is fascinating. Let me just do something extra, because if we now look at the chi-square, the degrees of freedom was 1 and the 0.5, the 0.55. It feels like something, somewhere I'm missing something, so I just want to make 100% sure about this one. And if that formula is correct. So everywhere it is the same. So that is definitely right. Observed minus expected. Okay, so that is correct. Okay, just want to do one more test to see why it is not. Okay, so that was the 0.84 that we have in our table. Okay, so we've got that at least. This is bothering me. Let's quickly check everything. That is right, that is right, that is right. That is right, that is right, that is right. That divided. Minus that. And so all the formulas is also right. When you add it. This is not doing what I wanted it to do. That is doing what it's supposed to do. Just want to check the last one, because otherwise we're not going to use this for you at the moment. I just want to make sure that that's also not going to work. Okay, so I will just check this why it doesn't compare. It should. Actually, so observed. That is where, so it should. So I will just check why it is not doing what it's supposed to do. Okay. So before we actually use this, let me just go and see why it is giving different answers, and hopefully one that actually has more information in the questions and not the rest is gone. We'll see that. But so what we got now out of this is we've worked out your test statistic, which is bigger than your critical value. So in this instance, we would have again rejected the null hypothesis. So let's just see the next one where we actually have an answer set, what we need to do. But I will check for you why that uh, um, is not working in Excel, because it should. Okay, so let's look at the next set of data. So here they tell us you got to test for independence. One of the variables has two possible categories, and the other has three possible categories. Okay, so you can think about it as I don't need to say it, but there's two rows and there is three columns. Then at least one can use it in the calculations. when they tell you, suppose that the calculated t-stat, that one that I now wanted to do, is 3,456 at the 5% level of significance, then they tell us, okay, but which one is correct or incorrect? So which one is incorrect? So the first thing is um, independent, not independent. So here they're saying the variables are independent, so that's correct. The two variables are dependent, so which also means not independent. So that is also correct. Then degrees of freedom is 6. So let's quickly check. Degrees of freedom is equal to r minus 1 times c minus 1. So what we get is r is 2. So 2 minus 1 times 3 minus 1. So 2 minus 1 is 1. 3 minus 1 is 2. So 1 times 2, okay, it's 6. So our degrees of freedom is the wrong one. Okay, but let's look at how do we get the critical value. So degrees of freedom is 2. Need to write degrees of freedom again. I can just say it's 2. So degrees of freedom is 2. So let's go to the table. Degrees of freedom 2. There they told us we're working with a 5%. So degrees of freedom 2, 5%. You can see the 5%. So also look at the alpha. So what they will give you in here is to say, well, 5% level of significance, which we know then alpha is equal to 0,05. What they sometimes can give us is the 95% confidence, which again ties back to 5% level of significance. So just again, so when they tell us alpha is 0.1, it could also be that we're looking at the 90% confidence. So things that, again, we nearly have is the other one that we use a lot is the 0,01 for 1%, which looks at 99% confidence. So that's nearly the ones that we will encounter in the stats courses. So, and this you don't need to prove, you don't need to even go to a lot of things, you can just use it. It's like the same, like I said on one of the chats, it's the same when we look at confidence intervals, the 90%, 95%, 99%, those numbers in that one table we can just use. We don't need to prove it. We don't need to work it out again. Okay, so we're working here with the alpha is 0,05. So alpha 0,05. And as we normally did with the Z table, where those two cross, that is the value that we referred to. It's 5,991, which is correct. And then if you look at, so normal table, so this one, and let's quickly show you, you can see it's a bit more skewed where normal table would have the peak in the middle. Here it's a bit skewed. So here it's a bit skewed to the one side, but very nearly similar to the normal table. So what we will do again is exactly the same. So let's they tell us the t-stat that we calculated is 3 point, and let's just say 3.4. Your critical value is 5. So your critical value is 5.9. So if that critical value is more than your t-stat, so let's just nearly write that again. If your critical value is bigger than your t-stat, okay, so it's in that. So fail to reject. So if it's failed to reject, we accept the null hypothesis. Okay, so accept the null hypothesis. If the critical value is smaller than your t-stat, then we will reject the null hypothesis. Okay, so again, I'll write this up for you as well, with an example like this, so that, and I'll just take a pic of it and share it on the WhatsApp group. I'll also put it in my UNISA portal as well, so that you can just use this again, so that you don't need to prove it when you get a question like this in the exam. You have a note with you so that you can see what you need to do. Okay, so again, if we look at this, the summary nearly of the things we did, look at independence, dependence, we looked at the degrees of freedom. We didn't need to work out that, but they given us the t-stat. They given us the level of significance so that we can check if a critical value is correct. And then we needed to make a final call if this is something that we will accept or reject. Okay, and this you will see nearly for all the rest is very similar in the questions nearly. So they again very similar. We just have one or two things different. Again, very similar in the approach that we need to follow. So when it comes to the goodness of fit chapter, or what we call chi-square table or chi-square test, nearly that summary of things are the things that you need to know. And again, I like to ask it in a question like 5 or 6, where you nearly test everything in one. Then it's much simpler for them to test two things or give you two questions on it that nearly covers everything in the study unit. Again, you will get nearly 2 questions per study unit in the exam. So this is very likely for hypothesis testing to be a question like this. Okay, so let's see what they now have done in this table. So they haven't given us all the information. They've given enough so that we can complete the rest of the table. But let's first check other things that's in here so that we maybe have eliminated things already. Okay, so which of the following statements is correct? Okay, so the two variables, so null hypothesis, the two variables are dependent. Okay, we know that's incorrect. For a null hypothesis, it's always independent. Okay, so we unfortunately need to go to the correct one. So first one, it's incorrect because null hypothesis always refers to independence. Okay, so this need to be independent. Observed frequency, okay, let's wait and work that out. Expected, let's wait and work that out. Okay, degrees of freedom, rows minus 1 times columns minus 1. Okay, there's 2 columns because there's only 2 variables. Don't ever use the total as an extra column. It only refers to the variables that we are looking at. So they might include totals in your table, but you don't include it as a variable. You only look at that variable and it to see if it is true or not. Okay, so rows we've got as acceptable or unacceptable, so that is 2, so 2 minus 1, and employees is Peter or John, so that again is 2 minus 1, so 2 minus 1 is 1, so basically 1 times 1 is 1, and that is actually the correct one. Okay, so again, when you guys do it, please look out for what I normally do is I check for those two and I check for this one first because that is the easiest ones to nearly work out. Okay, so, and hopefully if you're lucky, degrees of freedom is one of those that are the correct answer. Okay, so degrees of freedom was right. So let's work out the others. So what is the expected frequency of John? So basically, what is that value that we need to work that out? So how do we work that out? We basically say 950 minus the 265. So 950 minus 265. So that expected value of for X acceptable and John is 950 minus 265 is equal to 685. Okay, so it's 685 and not 668 or 665, so that was incorrect. The expected frequency of acceptable and employee Peter. Okay, so they're looking at that one, but they expected. So the expected frequency. So 265 is the observed value. Let's see if it is also the expected frequency. It might be the same, but let's work it out. So let's quickly, that total should be 300 because again 1000 minus 700 gives you a 300. So to work out that Peter and acceptable, we've got the 300 total times the 950 total. Remember that it is row total, column total, divided by the total sample of 1000. So let's see what that answer is. So 300 times 950 divided by 1000 is 285. Okay, so the expected value of that would have been 285. So that one is also wrong. Okay, so then suppose the calculated T-stat is 40 So let's go and check. So if your critical value is bigger than your t-stat, so let's see when we accept the null hypothesis. So let's quickly see your t-stat. They say it's 40. The critical value, and let's just see for 5%, we know it's degrees of freedom 1. So 5% degrees of freedom 1 is 3.841. So if the critical value is smaller, okay, so let's quickly, critical value is smaller than the t-stat, we will reject. Critical value is smaller than the t-stat, so we will reject. And they say we will not, because that is wrong, because we will reject. So again, look at this one was wrong, so we would actually reject it, and here they say H0 is not rejected. Okay, so again, nearly we looked at dependent or independent. We looked at the degrees of freedom. This time they asked us to work out the expected, and then they still used the t-stat versus the critical value for us to make a decision. Okay, so that again is another example of your hypothesis testing. Then here what they've done is they've given you the two, so the observed and the expected. And then they say, okay, but work out your t-stat. Okay, so let's now test this one with Excel. Okay, what happened here? Okay, so let's quickly, hopefully this now works. So let me just, I'm just going to copy this quickly over. So let's copy this over and see if it works in this. So things now change. We say male, female, and then yes, no, it's all the same there. So let's quickly see if we change the numbers. 23, 10, 36. Okay, so that adds to 22, that adds to a 59, that adds to 81, 35, 46. So at least we know that is correct. There we have a 9.51, 24, 12, and 33. Okay, so that is all correct. And if we then work out the t-stat, because we would have again said that minus that square root or to the root of 2 divided by that, and needed to repeat it for all 4. If we then add those 4 together, we get 1,5817, and normally we would round it off to 4 or even 3. So let's see. So all of these are rounded off to 4. So 1,5816. The answer should be 1,5. okay, 766. So what has happened with this one is in Excel, we worked with rounded numbers. Yeah, because you would have used these numbers, you would not have worked with a rounded, you would basically work with a rounded off number. So let's quickly, just to see if it actually, let's replace these numbers, because we will definitely then see the difference. And that's probably what happened with the previous one as well, is because we're working straight in Excel. Yeah, 1,5766, 1,5766. Okay, so if you would have used these numbers in the exam, just if I give you the expected numbers like this, rather put it into the Excel spreadsheet, that it doesn't work it out automatically, that it rather use those numbers, so that then you can get the right number. Okay, so if you wanted to do it manually, you will use that formula. So you would just then have said, okay, the 12 minus that to the power of 2 divided by that again, and you needed to do it for all 4 of them. When you add it, you will get also that option of number 1. Okay. Let me quickly stop here. Any questions thus far on this? And have you, I don't think this assignment open yet. Probably not. And maybe even for the 1510 guys that are checking in, I don't know if this assignment, your assignment is looking at study unit 10 yet. So it will be interesting later on when you guys do this to just give me feedback on what is in your assignment at the moment for this. They might also ask you in the assignment of study unit 10 some of the definitions. So just be from a theory point, with nearly look at slide 8 and 9, so that you have that. Just that is wrong. That is the T statistic that we need to use. So I'm just gonna quickly just paste it over that. It's in your, so the 1610 guys, you have a extra book that has formulas or problems in, and in that the test statistic for this chapter is wrong. So when they look there at the summary page, just check your how they summarize it is wrong. So that's why just look at your study guide for the T-stat. Okay, so let's look at, I think this is the last example that I have on this. Again, very similar types of questions. Firstly, okay, I see there's no hypothesis that they have asked here. I see degrees of freedom, so let's first do degrees of freedom again. We've got car size, small, medium, large. So that is your three columns. We've got the age of 1 to 3. So basically 3 minus 1, 3 minus 1. So that is 2 times 2, which is 4. Degrees of freedom is 4, is correct. We're looking for incorrect one. Just be and not careful, but all of these that we currently have worked through was or a 2 by 2 table or a 3 by 3 table. You can also get a 3 by 2 table where it is 3 ages and only 2 car sizes. So just it doesn't always need to be the same number of rows and columns in the table that you are working with. Okay, so then let's see, need to work out the expected. We need to check if the observed is correct. We need to work out the critical value. Okay, so let's do the critical value ones next before we do those. Critical value, we've got for alpha. So we've got for alpha 0.05. The degrees of freedom that we had was 4. So 4, let's quickly just, so 4 and across. So the alpha that we are looking at is 0.05 with degrees of freedom of 4. So your critical value is 9.488. Critical value 9.488. So that is also correct. Okay, so let's then observed frequency. Observed, I don't need to work out anything. I just look at the table, the frequency of buyers under the age of 30 who bought a large car. So 30, large, 34, 34 is correct. Okay, the expected one. So let's look expected frequency of buyers above 45 years of age. So we're going to look at that one. And bought a medium car. Okay, so we will need to look at that, above and medium. So expected is the total of a 1 is 99 times, so that was the 99 of the medium. The total of the above is 120. And that we divide by the total, which is 300. So again, that is the formula that we would have used. So 99 times 120 divided by 300 gives us 59.6. So 59.6 is what you wanted. It is correct. Okay, so the one that is wrong is option 5, but let's just look at it. So suppose that the t-stat that you calculated is 18.35. 18.35 is bigger than 9.488. Okay, so your t-stat is bigger than your critical. So let's quickly check where we wrote that. T-stat is going to be bigger than your critical. So we're going to reject the null hypothesis. H0 cannot be rejected. Okay, which obviously it's wrong because we are going to reject it. So H0 will be rejected. and that is why option 5 is the incorrect one. Okay, so, and I think I might have okay, so for this one, I actually have included some of the answers so that you can also see how the chi-square on the table was used, and also the critical or the t-test that is bigger than the critical value, so we will reject the null hypothesis. Okay, so you can see in the hypothesis testing or the goodness of fit with the chi-square, basically what is needed is these three slides that we look at. So, and let's do that first. The null hypothesis versus your alternative hypothesis. So it is independent versus dependent, which is that first set that you need to look at. Then you can actually put in here degrees of freedom. I know it is here that it is part of that, but you can actually already work out the degrees of freedom there. Then we look at the observed values. They need to give it to you, they need to give that to you, or they need to give you enough information that you can work it out. So like, where was that table? That there was empty cells, but they gave you enough to work out some of those empty cells. Then we can compute the expected frequency by following the number of rows, or sorry, the total in the row times the total in the column divided by the sample size. And then your last two things is you will compute the t-stat. You will basically look at your tables to get a critical value. Not tables, let's just do that. You will look at your tables and you will get a critical value so that you can work out your critical value with your t-stat to determine if you will reject or accept the null hypothesis. Okay, so that's in a nutshell nearly the summary of how you would go about in this study unit with goodness of fit. Okay, questions on this? Does it make sense? Is it a bit clearer? I will definitely send to you my original spreadsheet, and let me quickly show it to you that I just wanted to see where it is, the one that I have created for you guys, so that I think it's, let me quickly check as I open it up. Okay, so here you would see oh no, it's not this one. I've got another one, so don't worry. I will find it and I will share it on the group. So it covers all your study units within, so that you can nearly get all of the questions you can work out via Excel. I need to find it, but I will definitely share it. Okay. Other questions around this study unit at the moment that you're not 100% clear on, or um, that you think you might have issues with? Or happiness for now? You can just show a thumbs up if it is fine. Cool. Okay, so um, I'm gonna stop the recording so that I can share this as a separate study unit, and then I want us, and for the guys that want to stay on, nearly start with a recap of study unit 1 again. Um, and again, I will share that also with you afterwards, so that we can just, again, for the students that joined my group late, I was nearly trying to just hope that we can get you guys catch up on some of the things as well. Okay, so let's quickly um, take a minute or two. I'm just stopping. Sorry, I muted myself.